Okay, so we are going to discuss an example. Okay, so the example is this is the system which has been given. Okay, and what's been asked is to find all the fixed points of the system. Okay, then we need to use linearization method to classify the fixed points. Okay, so that's a part of the question. And another question is, once we classify, then using that information come up with a face portrait qualitatively. Okay, so that has been asked. Okay, first we will focus on the first part, identifying the fixed point and then classifying them. Okay, so now at fixed point this x dot has to vanish and y dot has to vanish. The interesting fact about this system is it's an uncoupled system. So it's like it doesn't matter what happened to y because of the change in x, right? So it doesn't affect actually. So x will not affect the change in y, and y will not affect the change in x. Okay, so let's say when x dot is 0, then this term has to be 0, and that will provide me some x value at which x will vanish. One is x is equal to 0, another one is x is equal to 1, and the third one is x is equal to minus 1. Okay, and from this, what can I say? From this I can say y dot will vanish when y is equal to 0. Okay, now the fixed point is nothing but both the things will vanish, and both the things will vanish at the point where this group and this group kind of pad. Okay, so like this. So this is one point, this is another point, and this is the third point. Okay, so these are the three fixed points. Okay, now we need to classify the fixed point. So in order to classify the fixed point, we need to identify the Jacobian matrix. Okay, and then once we identify the Jacobian matrix, that will be a function of x and y, and to classify a particular fixed point, we need to substitute the value of the fixed point, and then we need to use the linear technique. Okay, the technique which we use for linear system. Okay, first let's identify the Jacobian matrix. So what I have to do, I have to use this equations, and then I have to find this A matrix using this formulation. And if I do that, I will get this equation, which is in the form of x. Luckily we don't have the y dependence. Okay, fine. Now let's try to identify what kind of fixed point 0, 0 is. In that case, what I have to do, all I have to do is, in the place of x, substitute the x of this one, which is 0, and that will provide us the A matrix, which is this. Okay, and for this A matrix, what we can say, so what is the trace and determinant? So if you identify, okay, if you identify the trace and determinant, okay, we can easily say that it's a stable node. Okay, so we can say it's a stable node. So yeah, that's one fixed point which we have classified. How about the other fixed points? So for both plus or minus 1, 0, we are having this as the A matrix. Okay, right, so this is the A matrix, and from this we can easily identify that the trace is, sorry, determinant is negative. So Once we get to know the determinant is negative, we can easily say that it's going to be a saddle point. Okay. Oh man. Okay. Well, that's how you have to classify the you have to classify the fixed point. Okay, so now once you classify the fixed point, okay, we'll do the remaining thing in the next video.